Imagine standing on a beach in the year 2070, watching massive thunderclouds rolling toward the coastline. In the past, this scene would have triggered fear. Hurricanes destroying cities, storms flooding homes, winds tearing everything apart. But today, something different happens. As the storm approaches, hundreds of autonomous weather drones rise from hidden launch pads along the shore. Their wings glow with blue ionized light. AI satellites in orbit above Earth coordinate their movement like a swarm of intelligent birds. Ground-based supercomputers analyze millions of atmospheric data points per second. And slowly, almost gently, the storm begins to weaken. The winds lose their fury, the temperature shifts, and the hurricane dissolves like mist being wiped from a window. The crowd on the beach watches silently, realizing that they have just witnessed something humanity once considered impossible: the intentional control of weather. This idea used to belong to science fiction, controlling storms, redirecting rain, softening heat waves, stopping droughts, preventing floods, breaking hurricanes, slowing wildfires. For centuries, humans had no power over weather. We could predict it, study it, fear it, but we could never shape it. Weather was the ultimate reminder that nature is stronger than us. But as artificial intelligence becomes more advanced and climate change intensifies disasters, humanity begins asking a bold question. Can we use AI to tame the atmosphere? Can we take control of the sky? And if we can, should we? To understand this future, we must first understand how AI transforms weather prediction. In the early 2000s, meteorologists used massive models requiring hours of computation just to predict rainfall. Forecasts were often wrong, hurricane paths were uncertain, and natural disasters struck with little warning. But in the 2020s and 2030s, artificial intelligence revolutionizes atmospheric prediction. Neural networks learn how the atmosphere behaves by training on decades of global satellite data, trillions of data points representing wind patterns, temperature layers, ocean currents, moisture levels, jet streams, and storm microdynamics. AI doesn't just predict weather, it understands it. AI models can now simulate storms at resolutions humans never imagined. Not 20-kilometer grids, but 1-kilometer grids, even 100-meter grids. Every tiny behavior inside a hurricane or typhoon becomes visible. AI knows how storms form, how they intensify, how they travel, and even what conditions would stop them. Suddenly, scientists realize something astonishing. If you can understand the atmosphere at microscopic detail, you might also influence it. This realization triggers a new field: climate engineering powered by artificial intelligence. Imagine a deadly hurricane forming near the Caribbean. Traditionally, governments could only warn citizens, evacuate cities, stockpile supplies, and pray. But in the future, AI identifies the exact temperature gradients in the ocean that feed the storm. It calculates the precise atmospheric pockets where disrupting airflow could weaken the hurricane. It maps out the most vulnerable structures on land and recommends targeted cooling techniques over the sea using fleets of drones. Just as a surgeon delicately operates on a human body, AI becomes a surgeon for the planet's atmosphere. Let's walk through this future step by step. AI satellites orbiting Earth scan the atmosphere continuously. They detect water vapor density, cloud microphysics, solar radiation, wind shear, and thousands of climatic variables in real time. These satellites communicate with high-altitude weather balloons that float like silent guardians, measuring the atmosphere from inside. In the oceans, floating robotic buoys analyze temperature layers and humidity, sending data to AI supercomputers. Weather drones, resembling mechanical butterflies, fly into storms, gathering hyper-precise data. All this information flows into a global AI brain, a planetary weather model capable of identifying disasters days earlier than any human meteorologist. Now imagine the AI detects a hurricane forming. Instead of letting it grow, the system activates Phase 2, weather modulation. Hundreds of drones rise into the sky carrying aerosols, salt particles, cooling chemicals, or ionizing beams. They release substances very strategically to either increase or decrease cloud formation. High-powered lasers fired from orbit cause micro-changes in atmospheric water droplets. Giant offshore machines pump cooler water to the surface, weakening the heat engine that fuels hurricanes. Thousands of these actions, microscopic on their own, combine to slightly alter the hurricane. And because weather systems are chaotic, even a small shift early on creates a massive effect later. The hurricane arrives at the coast not as a monster of destruction, but as a mild storm. Now imagine the possibilities: no more Category 5 hurricanes destroying nations, no more deadly heat waves killing thousands. No more wildfires consuming entire forests. No more drought devastating crops. No more sudden floods washing away homes. AI turns the atmosphere into a manageable system rather than an unpredictable threat. But as breathtaking as this future sounds, it comes with immense risks: ethical, political, environmental, psychological. Consider drought control. In Africa, India, Australia, and regions suffering long dry seasons, AI can guide cloud seeding drones to create artificial rainfall. The system doesn't simply make it rain, it analyzes global humidity patterns to determine where rainfall will cause benefit versus harm. It ensures water vapor is not stolen from neighboring countries. It prevents excessive rainfall that could cause floods. Rain becomes a programmable resource. Farmers rejoice as fields receive perfectly timed rain. Cities reduce water crises. Rivers refill. Food insecurity begins to fade. Now imagine wildfire prevention. AI identifies forest regions at risk due to dry air, high heat, or flammable vegetation. Before a fire starts, the system sends drones to increase humidity or lower temperatures. Controlled micro-rains occur. Forests become damp enough that wildfires never ignite. Entire ecosystems are saved before disaster even begins. But now imagine the darkest possibilities. Weather becomes not only a tool of safety, but a tool of control. Nations may fight for weather dominance. If one country cools its atmosphere, another country could experience unintended drought. If one region increases rainfall, another might face floods. Weather becomes geopolitical. Climate manipulation becomes political power. AI could be misused, either intentionally or accidentally. Imagine a hostile government using AI weather control to create artificial drought in another region, or corporations influencing rainfall to benefit agriculture markets, or mistakes that backfire. Cooling efforts that accidentally cause massive storms, cloud seeding that goes wrong, or atmospheric engineering that triggers side effects nobody predicted. The planet's weather system is interconnected. Altering one region affects another. Even with AI, uncertainty remains. And then there is the ethical dilemma. Should humans control nature at all? Is it morally right to interfere with atmospheric processes that evolved over millions of years? Should we override nature's cycles or respect them? Climate engineers argue that human industrialization has already changed the climate, and AI weather control is simply a corrective tool. Environmentalists fear that interfering too much could destabilize ecosystems. But perhaps the biggest concern is dependency. If future generations grow up in a world where hurricanes are softened, droughts prevented, rain controlled, and heat waves minimized, they may lose their respect for nature's power. Humans might become complacent, assuming AI will always save them. Yet what happens when AI systems fail? Solar storms, cyber attacks, energy shortages, geopolitical sabotage, all could disable the global weather control network. A world dependent on weather control may be vulnerable without it. Still, despite these concerns, the benefits are overwhelming. AI weather control saves millions of lives. It protects coastal cities, it reduces climate refugees, it prevents crop failure, it stabilizes global food supply, it reduces economic damage from natural disasters. Insurance markets collapse because disasters no longer produce massive losses. Human societies gain stability. Now picture a world where weather forecasts are not merely predictions, they are schedules created by AI. Today, light rainfall at 3 p.m. Tomorrow, humidity controlled for forest fire prevention. This weekend, clear skies for festivals. Weather becomes a programmable environment. Cities run weather apps that literally tune their skies. Megacities covered in solar panels request sunlight hours for power generation. Farm regions request rain for crops. Ski resorts request snow on demand. The world becomes a network of climate zones optimized by AI. But here's the final and most profound question. If humans control the weather, do we still live in nature, or do we live inside a technological simulation of climate? Humanity once feared the sky, storms, heat, rain, winds. Then we learned to predict the sky, and now we stand at the brink of rewriting the sky itself. AI weather control may not eliminate all disasters, but it may weaken them, reduce them, predict them early enough to neutralize them, and alter them before they become deadly. The idea is no longer science fiction, it is the next frontier of climate science. Whether AI becomes a guardian of Earth's atmosphere or its greatest disruptor will depend on the wisdom, ethics, and responsibility of the humans who control it. Because when you have the power to command the sky, you also carry the responsibility of protecting the world beneath it. Hi, I am Dr. Mohsin Raza and hope you enjoyed the video, but don't forget to subscribe the channel for future videos.